So now I'm going to describe two kinds of optical detectors, which is prevalently many times you are using in the laboratory environment. So first is a photomultiplier tube. What does photomultiplier tube mean? Because it looks like a tube. This is inside a vacuum tube, which is kind of rare in this modern age. But yes, we do still use this photomultiplier tube, or we call it PMT. And if you look at inside, and this is a simple diagram, although it looks a little complicated, but let's take a look. When the incoming photons get in, you see there is a photocathode. So this will eject a photoelectron, and that photoelectron is a negative charge. So you actually have a very, very negative voltage applied on this, so that the electron accelerates to hit this metal surface, and we call it as a secondary emission, that photoelectron ejected, and another probably about 100 volt higher than this, so that the electron moves toward hit, and then there's a more number of photoelectrons, and we do this over and over again, reaching this final electrons getting into this electrode. We call it anode, because this part is cathode and the other part is anode. So a huge amplification or multiplication of photoelectrons getting in to generate a photocurrent. So that's the principle of photomultiplier tube. And you can see how we can make this, like, let's say 100 volt higher, reaching to the enormous multiplication, which is about 10 to the 5th to even 10 to the 8th, like 100 million times higher number of photoelectrons to create a current. So PMT generates a vacuum tube that converts the incident photons into the current. So to generate this, you need a circuit with a high negative voltage power supply, and then you have this voltage dividing circuit to provide, let's say, minus 800 volt, minus 700, minus 6, 5, 4, 2, 1, 0 volt. And then you collect those photoelectrons. So PMT is incoming photons are absorbed by photocathode, generating electrons by yes, here comes photoelectric effect. And the current is amplified by cascade of electrodes. We call this, in the middle, this electrode as diodes. This is just a historical reason to put this diodes name. And what's interesting here is the PMT has a high sensitivity, even single photon sensitivity that it provides. So this is a real proof that the photon, the light, is composed of photons, okay? Single photon sensitivity with a available photon counting mode, which means because it's a photon, even single photon gets in, we detect the signal, then we can even count the photon. This photon counting mode is very useful in very low light condition experiments. Then each single photons can be separated, and in the middle noises can be eliminated by comparison with a threshold. We call it as a discriminating photons from a noise. Okay, so I just want to have an expanded picture of this. You can see these are the diodes. Can you see? That's similar. So where do we use the PMT? So PMT is used for very low light level spectroscopy, UV visible spectroscopy, and also in microscopy, especially laser scanning microscope, which we detect photon from each single pixel over time. Sequentially, we use PMT. So confocal microscope to photon microscope, and even in medical imaging and a basic science, in astronomy, to detect photons or gamma rays, in medical field, radiation these we can also use for medical imaging with these PMTs.